Your Excellency, ladies and gentlemen, good afternoon. Welcome to the STEM complex at the University of Ottawa. It is really our great pleasure to welcome His Excellency Stefan Peringer, Ambassador of Austria, and Dr. Konrad Bergmeister from the University of Natural Resources and Life Sciences in Vienna, Austria. We are really honored to have them visit us here in the Faculty of Engineering in our very new STEM complex. In fact, it's so new that, as you can see, we still have some ongoing work in the atrium. This is a building that we inaugurated last September. One of the elements that pleased us so much about this new building is all the civil engineering research labs tended to be in a deep, dark cellar close to King Edward for many, many, many years. And now we have the opportunity to bring them much more to light, much more visible, much more exciting and interesting for the students in this very building. So that is one of the really exciting aspects. It's also a building where we support the entrepreneurship of our students and their ability to design projects and actually fabricate them. This entire ground floor is devoted to makerspace and design projects and team space and augmented and virtual reality labs. So we're very, very pleased with this, this new complex. This is excellent timing for the talk that we will hear today. The City of Ottawa has had to dig a few tunnels over the last few years for the new LRT train system. And it's also very timely because we've even heard in the news talks about potentially adding another bridge to connect the City of Ottawa and my hometown, which used to be called Hull, which is now Gatineau, just across the river. So we look forward to hearing much more about the Brenner Base Tunnel. And on that, I will invite Your Excellency to say a few words.
Honorable Dean, professors, members of the academic community, City Councillor, President Birker, dear Roland, dear friends, I certainly don't want to take too much of your time because I guess you all came to hear from our guest of honor, Professor Bergmeister, to talk about this very important project, which is, I would say, nothing short of historic. Some would even call it pharaonic. A project which brings together Austria and Italy, but transcends far beyond just an Austro-Italian cooperation. It is a project, and I may add that from a political view, and having served to our former Prime Minister, or Chancellor as we call it in Austria, as a diplomatic advisor, which is of an outstanding political importance for linking Europeans. I mean, you may have heard about the idea of the trans-European networks. We'll go from the north to the south, from east to west, from basically the idea of linking Helsinki with Palermo. And when we intend to do that, we do much more than just building railways and tunnels for railways, but it's the political impact of linking people, of bringing people together, and especially in a country like Canada. We just had a brief conversation on that, which essentially was brought together by infrastructure, things of channels, of the telegraph lines, and also of railways, both in the east and in the west of Canada. I think especially in a country like Canada, one has a lot of understanding for the importance of infrastructure in bringing countries and bringing people together. That's what we do in Europe. You know that we have enormous challenges ahead in Europe facing us all the time, and especially in this moment. And I think that the Brenner Base Tunnel, I think the inauguration is projected for 25 or 26 or 27. We will hear more about that. I think this is a good step forward to also make clear to our citizens that the European Union is is able to taking steps forward in our aim to create an ever closer union and friendship among the people of Europe. And we are very curious about Dr. Bergmeister telling our Canadian friends and us about this very important project. Thank you all for coming. Thank you again to the University of Ottawa for the cooperation we have. I may add that within a month, this is our third project we have with the Ottawa University. Thank you for your continuous support, and we are looking forward to continuing that. Thank you so much.
Your Excellency, newly elected member, Jean Menard, sorry, he's a friend of the family, and I'm so happy to introduce you here, and with your friend and colleague also from the city of Ottawa. Sorry, I just been given the cards, so that's why I'm maybe not in the chronology I should greet people, Mr. Gontier. And if anybody has any problems with him, please just call him, because he is a director of infrastructure. But today also we'd like to thank the Dean, Jacques Beauvais. No, it's not a start of a song. It's also would like to welcome your Dean Jacques Beauvais. Then I also have Colleen Rennie, the Faculty of Engineering, who we originally started with. Then we had also here just met Mr. Adel El Zaim, Chief Internationalization Officer. Engineering students, friends, ladies and gentlemen, I'm happy that so many came this afternoon. My name is Roland Perker. I'm the president of the Austrian Canadian Council, national charity, and we have sort of together with the university and the Austrian Embassy made this event possible. But I'd like to thank His Excellency specifically and his staff, Mrs. Miller, Mrs. Simpian, for their support. I mean, I was away for 8 weeks in Mexico, so they did all the work. I only initiated it. But also I'd like to thank the university for the facilities and for making, food and drinks available. Thank you very much. That's very kind of you. Last year in September, I guess I better speak into the microphone. Last year in September, I was in Innsbruck, a part of the Austrian expatriate community, and there I had the chance of visiting the tunnel project, the Brenner Tunnel project. And when I heard and what I saw, it was so impressive that I said, wow, this needs to be something for Canada also. Some interesting thing, especially with the talks of a tunnel or a bridge. And I think to me, it's a no-brainer. A tunnel is the answer to go over to the other side, because you don't interfere with anybody's vision. But anyway, when I asked Dr. Bergmeister whether he would come to Canada and give a talk, he said yes, providing you have students in attendance. And thank you for all the students. Can you please raise your hands here, the students? Oh, wow, thank you very much. Because as he said, you are the future, and we need to have you exposed to a lecture like this. Anyway, when he said he's coming, I said I'm delighted, and the rest actually is history. So I'd like to just read to you this impressive resume of Dr. Bergmeister. Studies in civil engineering and studies in ethnology, history of art, philosophy. He graduated in both Master of Manufacturing Systems at the University of Clarkson, New York, USA. Doctoral degree in philosophy, University of Innsbruck. Doctoral degree in technical sciences, University of Innsbruck. Doctoral degree in macroeconomics, European University of Bratislava and Vienna. 1990, founder of a civil engineering company. From fall 1993, university professor at the Institute for Structural Engineering in Vienna. 1999 to 2006, chief engineer and technical director of the Brenner Highway. Since 2006, Chief Engineer and Technical Director, since August 2006, CEO of the Brenner Base Tunnel. 1999, Chief Editor of the journal Beton und Stahlbetonbau, Concrete Reinforcement Concrete Structures. 2003, Editor Betonkalender with Fingerlus Werner, member of IABSE of FIP commissions and various National Committee Structural Engineering. Wow, what it was. Full member of the Berlin-Brandenburg Academy of Sciences and Humanities. Full member of the National German Academy of Sciences Leopoldina. Full member of the European Academy of Science and Art, and honorary professor of the Jiang Guangzhou College of Technology in China. 650 scientific publications and 5 books. Gentlemen, I give you Dr. Bergmeister.
Excellency, honorable professors, dear friends. I would like to thank you, all of you, that you are spending 1 hour for me. We are trying to interact, and should be only the beginning of a future collaboration. So the idea would be to do something together, try to promote some collaboration between Canada, between Austria and Europe. It doesn't work, it should work. So I would like to talk in the next 3/4 of an hour about the vision of the so-called Trans-European Network, which was developed 30 years ago. I'll give you some more detail about the project itself, the design philosophy, construction, logistics, and finally also spending some few minutes about the cost and risk management, which is quite important as well, talking about innovations, and finally the social impact, including all the issues about communication. This is a picture of the so-called Trans-European Network, which was developed more than 30 years ago. And in 1992, they had the idea, if we want to create a unified Europe, then we have to do something. We have to promote, and this is always also my philosophy, we have to promote the exchange of the young generation. We have to promote the student exchange, and we have to create infrastructures in the way that the people can come together, the people that they can communicate together and create business and social impact together. Now, in 2012, the European Commission reduced the corridors from 32 to 9 corridors. So the idea is now to have those 9 corridors working, let's say, in the next 20 years. This is a task which needs a lot of support, a lot of real development. And if you take a close look together with me, then you see actually the so-called ScanMed corridor starting in the Nordic countries, Finland, crossing Sweden, Denmark, Germany, Austria, and coming down to Italy. Now we are focusing the attention to the Alps. This is actually a picture about the traffic flow, the heavy traffic flow across the Alps. The last year, in 2018, we had more than 200 million of tons crossing the Alps. On the one hand side, it is quite important to promote business, to promote the economy. On the other hand side, the lorries are creating a lot of environmental impact. And they are destroying the living environment. And if you calculate the actual traffic situation crossing the Brenner Pass, then we have on 350 days, 7 days per week, 24 hours, every 12 seconds a heavy truck. it is quite clear that this cannot be healthy. And so the idea since already a long period of time was to create a modal shift from the road to the rail. But what do we need? We need, first of all, infrastructure. We have to create the capacity on that. Then we have to offer a certain quality of service. And finally, we have to create a so-called transport supply chain. So you have to create a so-called point-to-point transportation system. Otherwise, it will not be accepted by the passengers or by the industry. The Brenner Base Tunnel itself has a long story. It was, the first idea was already developed in 1847. But after that, they took the decision, no, we are not able to develop such a big tunnel crossing the Alps. We want to create a traditional railway. And the traditional railway was actually started in 1859, exactly the same year when Ottawa was founded. And 6 years later on, they have been able to take the railway line with a total length of 125 kilometers into operation. 6 years, ladies and gentlemen. Today, in our time, we are thinking much longer, we are approving much longer, and we need, as you see over there, 40 years. From the feasibility study, the optimization phase, I was involved in that phase at that time as a young professor, together with 30 international experts on a worldwide level, and we tried to optimize more than 250 different proposals which have been made in the so-called feasibility study, and we reduced them to 3 variants, to 3 proposals, working out the different issues from a technical standpoint of view, from an economical, from an environmental, from a social impact, and finally also from a cost-benefit standpoint of view. Then the preliminary project, the definitive project was worked out, and after 40 years, we will be able to take the railway tunnel in 2028 into operation. Now, who is developing the project? This was a quite smart decision to create, let's call them an interface company between Austria and Italy, a so-called Societas Europaea. This is nothing else as a combined company between the Austrian experts and the Italian experts. Today, we do have 50% of the stakeholders are the Austrian Railway Company, and the other 50% more or less are the Italian Railway Company, with some small percentages still held by the local region. And this is also quite important to include, to involve the local regions as well. Then, what is with the decision-making processes? This is a big issue. In order to satisfy both countries, they created a board of CEOs. 2 CEOs have to take the decisions. The presidency is a rotating presidency with a supervisory board of 6+6. We have, and this was very smart, they created a so-called intergovernmental commission. This commission is used as an exchange commission, and the real politics, the real strategy is made within this commission. So in that commission, representatives of the foreign ministry, of the internal ministry, of the finance ministry, of the ministry of transport and constructions are sitting twice per year together, and they are reflecting the strategy, the future strategy. They are not making any decision, they are preparing the decision, and this is the important issue. And finally, we have some working groups talking, dealing with operational issues in the future, dealing with very specific technical issues. And this is another big, another issue that we are trying always to include, to involve external experts, trying to open the windows to invite them. Now, in 2007, when we had a very nice meeting together, and we have been quite enthusiastic that we will be able to start the project now. We are ending, it was the final phase of the so-called definitive project. We had the reflection, what can be done if the tunnel is ready, if the tunnel is actually ready for operation and nobody uses the tunnel. And so we came together, we had a bottle of white wine, and we came up with the idea that we have to create a so-called corridor platform, involving the three ministers from Germany, Austria, and Italy, in order to promote a corridor approach, not only a single project, a corridor approach. The regions between Munich and Verona, the railway companies, and we came up with a so-called action program dealing with greening and environmental issues, dealing with traffic policy, with modal shifts, with corridor approaches, with cross-financing and so on. And we wrote 80 different actions. They are evaluated on a yearly basis. They are coordinated and promoted within 10 working groups. And this was a very important accompanying measure in order to promote, in parallel to the tunnel construction, all the additional issues which are needed in order to create finally not only an infrastructural project, but to create a real, let's say, connecting project between people and business communities. This gives you a little bit the flavor, connecting Germany, Austria, and Italy, a flavor what is going on along a stretch of 400 kilometers, 3 countries, 3 different philosophies, 3 different nationalized railway companies. And we are not going into detail, but it gives you the idea that the whole corridor is in a progress. And this is the important issue. Certainly, it was started on the Austrian part. Now we are under construction with the Brenner Base Tunnel. And so the idea was to create not only the base tunnel itself, which starts over here in the surrounding area of Innsbruck, using the existing bypass of Innsbruck and running actually more or less in a direct way, underpassing the Alps of a total length of 64 kilometers. You see over there the existing railway line, which will be kept also in the future for the local traffic and so on, and the new layout of the tunnel project itself. And now we are listening for a couple of minutes to a video which gives us a little bit a flavor about the project itself.
The works on the Brenner Base Tunnel are divided into construction lots. The current lot, south of Innsbruck, includes the Tulfes area up to Steinach am Brenner and involves a total of 42 kilometers of tunnels. Besides the Innsbruck bypass, which runs from Tulfes to Beberbach, between 2014 to 2017, a parallel running emergency tunnel was built from the Puerstl in Tulfes to Aldrans. The entire 9-kilometer stretch is being excavated by blasting. In summer of 2017, the excavation of the tunnel, which was driven from 3 points of attack, was completed. The miners and engineers meet at the final breakthrough. Today, thanks to the extremely high precision of modern surveying techniques, it is taken for granted that the tunnel tubes will meet up perfectly. But even so, every breakthrough is a special and emotional time.
Mit einem herzlichen Dankeschön, mit einem herzlichen Glück auf.
Cross tunnels connect the bypass tunnel at 333-meter intervals with the new emergency tunnel, thus bringing the railway bypass tunnel in Innsbruck, which has been operational since 1994, into compliance with subsequent safety requirements. This was the reason for constructing the emergency tunnel. Here, about 160 meters below the town of Aldrans, 2 connecting tunnels branch off from the existing railway bypass in the direction of the Vip Valley. These two tunnels create a crossover in order to allow a fluid transition between the right-hand running in Austria and the left-hand running which is used in Italy. The two connecting tunnels took only 2 years to be constructed. The breakthrough took place in the summer of 2017, creating an underground connection between the Inn and the Vip valleys. Times like these give the miners and their colleagues pause, and relief is plain to see on their faces. Once the excavation works are completed, the internal lining of the connecting tunnels will begin. Inflowing mountain water is drained off to the tunnel invert by means of an insulating film, and thus any moisture is kept away from the tunnel. The reinforcement is then assembled. In blocks of 12.5 meters each, lattice mats and steel bars are woven by hand into a mesh, which gives the concrete stability and durability. The tunnel inner wall is then filled with concrete block by block using mobile carriage molds. The consistency of the concrete, the placement and compaction are precisely coordinated so that the concrete has no defects and reinforcement is completely embedded. After the formwork has been stripped, the concrete is treated with a foil seal. This controls the temperature and humidity of the concrete and minimizes cracking. For the first time in tunnel construction history, the Brenner Base Tunnel is being built to last at least 200 years. The exploratory tunnel is located centrally between the two main tunnels and about 12 meters below them. This is where the first TBM in Austria territory was used for excavation work. Since November 2015, the TBM named Günther has been cutting its way through the rock, driving 15 kilometers of the exploratory tunnel from Steinach am Brenner. Starting from a chamber below the town of Patsch, which is connected to the surface by the Arental access tunnel. The exploratory tunnel provides information on the geological characteristics of the rock mass, and will therefore make the subsequent construction of the main tubes efficient, fast, safe, and cost-effective. The TBM is 180 meters long and has a diameter of 8 meters. The boring machine head is equipped with disc cutters, which rotate slowly and constantly, while the TBM pushes hard against the rock face, digging its way through the mountain.
Danke. Yes.
Behind the cutter head, the backup provides for consolidation work through installation of tunnel linings and anchors, steel ribs, reinforcing steel mats and shotcrete. The tunnel floor is built with prefab concrete elements, the so-called tubbing rings. Fully automated multi-service vehicles shuttle back and forth to the TBM to supply construction material, concrete, and prefab elements. Tunnel spoil is transported on a conveyor belt system. All material taken from the mountain must be returned to nature. Here in the Arental Valley, approximately 2.6 million cubic meters of excavated material will be relocated along the Brenner Highway. Great care is taken to ensure that the disposal site is embedded into the landscape in the best possible way, to create new available land in the future that will be gradually replanted and covered with green growing things. Another construction site for the Brenner Base Tunnel is located in the municipal area of Steinach am Brenner, in the district of Wolf, where the Wolf construction lot was completed in the summer of 2017. The works of the Wolf construction lot, which included the construction of the 4-kilometer-long access tunnel, a large underground chamber, and 1.2 kilometers of the exploration tunnel, started in 2013 and were completed in the summer of 2017. Subsequently, further excavation work northwards and southwards, the construction of the Sant Jodok emergency stop and of the stretch of the exploratory tunnel towards the Italian border will start from here. Soon, several tunnel boring machines will be put into service at this site. The largest disposal site for excavation material, the Puerstl Valley, is also located in Steinach. After the completion of construction works and revegetation, this deeply cut valley will become arable land. The Puerstl Brook will be rerouted to a new bed on the surface, and new wooded and pasture areas will be created. About half of the excavation material of the Austrian project area will be deposited here. The excavation material is transported to this disposal site using underground conveyor belts, and the local residents hardly notice it.
People always ask me, what are compensatory measures? Working in BBT SE, we are aware of the effects of major construction sites. Therefore, we do a lot to compensate those impacts. And this is also why we finance and implement significant improvements to habitat and nature in our project area. Habitats, wetlands, and moorland are revitalized and expanded as recreational areas for the population. The river courses of the Isarco River and the Marita and Sil brooks are being rerouted. This means fish can swim upriver again and reach their spawning grounds, and these mountain brooks will regain their original characteristics. In the next few years, a total of 250 such compensatory measures will be implemented.
In the BBT tunnel world in Steinach am Brenner, near the valley station of the Bergaraum ski slope, information about and closer glimpses of the major Brenner Base Tunnel project are available throughout the year. In 800 square meters of exhibition space and in the display tunnel, you can experience tunnel construction in a fun and instructive way and get the latest information about the project. Not far from the tunnel world, the new circular walking path in the Puerstl Valley offers a spectacular view over the disposal site and provides information on the spot about the site and the nature-friendly measures which were carried out. Once a year, the tunnel construction sites in North Tyrol and South Tyrol are opened for interested visitors, such as in October of 2017, when thousands of visitors got the chance to see the fascinating world of tunneling up close on the Arental, Mullers and Isarco River underpass construction sites. Employees of BBT explain facts about tunneling, geology and topography. Tunnel tours make it possible to view the work in progress in the project area. A special entertainment program for all ages makes the open tunnel days a special experience. And who knows, perhaps someone will have the chance to find their true calling.
So this gives us a little bit of flavor about the project itself, and now I would like to continue with the presentation, talking a little bit more into detail about the different issues regarding the project itself. It is a base tunnel. We are trying to reduce actually the slope, the existing slope of 28 per mil to approximately 7 per mil. So it is a real base tunnel. As you saw already, there are 3 tunnels. Why? The so-called exploratory tunnel is used on a worldwide level the second time. The Channel Tunnel between France and London has also 3 tubes over there. But the third tube, the middle tube, is used for maintenance and for emergency purpose. Our tunnel is used for, first of all, exploring the rock mass. Secondly, for additional services during the construction phase. And finally, is a possible tunnel taking all the rail equipment, what we need, the machinery, the ventilations and so on, they can be placed over there in order to have no interaction with the existing under operation staying main tunnels. And this gives us a big advantage regarding to other big base tunnels like the Gotthard tunnel. They do have only 2 main tunnels. Finally, as you see over there is a so-called water channel. This is nothing else, it's a drainage system for the water which is normally collected above the rails. But in order to polish the drainage system, to clean that up, you have to close a tunnel. And this is done, for example, in the Gotthard tunnel 3 times per week. 3 nights per week. They have to close the tunnel for maintenance purpose. In our specific case, we are trying to reduce that as much as possible. The emergency areas, you saw that already before, they have been developed in a different way. It will be the first tunnel on a worldwide level that you can achieve with some car directly the emergency areas. And this is a very specific layout. Every 20 kilometers, on the basis of the European codes, you need a so-called an emergency area. If when a train runs into the emergency zone, burning fire on the train, then the passengers can go out, they can walk to the central safe area, and another so-called evacuation train can come and pick them up. With our specific access tunnel directly connected to the central safe area, we are able to take the passengers out also with some cars. And this is a big advantage. You see it in another layout over here. It's a quite complicated, from a geotechnical standpoint of view, not an easy system. But nevertheless, this is the exploratory tunnel. The main tunnel, the cross passengers tunnel, over here, every 333 meters, specifically in the emergency zone, every 90 meters. And then we have in the middle the so-called safe area zone, and above them the ventilation system, which extracts some air or some smoke coming from a possible fire and so on. Now, the rail equipment is another big issue. It is a very easy task on the one hand side. On the other hand side, we have to prepare the tunnel layout also for the future, for the next upcoming technologies. And therefore, we try to have the carriageways laterally on the same level in order to implement, probably in the future, also some magnetic system. Or there is the so-called electrical supply. And there are different voltages. In Italy, 25 kilovolt, in Austria, 15 kilovolt, 16.2 of hertz, different frequencies and so on. And this makes the life a little bit more interesting. Now, the main data are 64 kilometers length. The total length of the whole tunnel system is 230 kilometers. With a maximum overburden of 1,800 meters, you don't feel that if you are in the tunnel. The maximum speed of the freight trains will be 120 kilometers, and the passengers 250 kilometers per hour. Before we started the project, beginning with 2001 approximately, we started with some exploration drillings. Vertical drillings having a diameter of 100 millimeters approximately, and we did a lot of them. But finally, when you start a project, then you see, you know only a little bit. 27 kilometers means approximately 40% of the total tunnel length have been drilled vertically. And I did once some research on comparing other projects. In the Gotthard tunnel, they did approximately the same vertical drillings. In the Semmering tunnel, having a length of 27 kilometers, they did almost 90% of the total tunnel length. So it depends on the complexity of the rock mass and also of the financial possibilities. Now, it is more or less related to the engineering world, what I'm talking about now. In a normal project program, you are carrying out the feasibility study, the preliminary project, the definitive project, and some executive project. We developed a guide design phase between the so-called procurement phase and after the definitive project. We had different environmental measures in Italy and in Austria, different philosophies and so on. And I come up with the idea, what can we do having different design procedures in both countries? So we developed our own design procedures, we developed our own guide design on the basis of a so-called holistic approach, including not only the structural safety, robustness, serviceability, but trying to include also the maintainability, the life cycle management, including also the environment, the society, the social performance. And we came up defining for the first time in the world for a big project a life cycle approach, including the different cycles of maintenance, of upgrading, and so on. And we developed our own design procedure on the basis of a service life of 200 years. Certainly, this was something which was not known before. We studied it on the basis of the existing probability models, and we came up with some proposals in terms of safety factors, in terms of structural measures, and so on. But the idea behind is to develop life cycles for the tunnel structures, for the ballastless track, for the ventilation system, in order to have, like as it is known already in the facility management for buildings, to have a clear picture about inspections and maintenance and about the costs during operation. This was the idea. Now we had to optimize also the so-called surveying process. Since we know, since a couple of years, we know that also in Europe that the globe is not anymore a plate. It is it is a circular. The problem was that we had to shift, let's call them the reference level, from the center of the globe up to a level of 770 meters in order to reduce the so-called surveying errors, the aberration errors. And we have been able, by doing so, shifting them up of approximately 700 meters, we are able now to do a very precise surveying. And when you will see that also later on, you saw it already in the film, when the two groups are coming together, excavating a total length of, at that time, 12 kilometers, we had a tolerance of 2.5, 2.4 centimeters, 25 millimeters. So it is quite precise. Monitoring and surveying the existing buildings. We had to underpass villages, very expensive ones, housings and so on. And you can imagine if you underpass in a certain area and if some bedrooms have been built 20 years ago, you don't like it anymore, and so you see a lot of cracks later on. And therefore we have to do the monitoring, the surveying before and after the construction work. On more than 9,000 buildings. They are documented very well. They are with the digital imaging system documented, described the structure itself, in order to have a little bit of documentation about the building quality. The so-called water resources is another big issue. We developed a so-called monitoring program since 2001 of more than 1,300 water resources, measuring the conductivity, the pH value is a chemical parameter, the temperature, the quantity, and so on. And I was very surprised, and I'm still surprised, how precisely they can detect in the tunnel, having an overburden of more than 1,000 meters, from which water resource the water in the tunnel is coming. And it is amazing for me how precisely they can distinguish the composition of the water in the tunnel. We are doing the measurement on a monthly basis. We are delivering the data on every second month to the authority. The geology. Clearly, it is another big issue. We have a very weak geology in the northern part, in the surrounding area of Innsbruck. The phyllites, we have the schists here, the blue one, the gneiss and the granite, which is a very hard stone material, a very interesting building material as well. 2/3 of the total exploratory tunnel, approximately 40 kilometers, have been already excavated. So we know a lot about the geology. We know a lot about the aggregates and the composition of the stones. But now the problem comes in that we have, on the one hand side, try to reduce the disposal areas, the disposal volume. We want to reutilize the excavation material as a building material, which is also the basis of the sustainability. And we have been able finally to work out, together with universities, with 5 PhDs, a system, a proposal to recycle the schists with a uniaxial compression strength, which is quite high, 75 megapascals. But we have been able to figure out, and this was quite interesting, that the weakest, let's say, fault zone of this specific stone is not by 90 degrees. If you have a stone over there, you would imagine that you cut them vertically on 90 degrees. No, it is 40 degrees. And by cutting them with 40 degrees, we had to remodify the cutters, and we have been able to develop, to create some aggregates which are usable to produce concrete. And we are now able to recycle approximately 40% of the excavation material. We are studying also the durability, and this is another big issue. If you have to deal with a very long service lifetime, then you have to study that also. And we are studying the permeability, which is quite new, which was not known in the past, since normally you are measuring the concrete strength, you have the compressive strength, probably also the tensile strength, the modulus of elasticity, the carbonation. But it is not so known that the permeability plays a very important role in terms of durability, in terms of fire resistance, and so on. And we did a lot of intensive study on that, and we came up on the basis of the Fick law. We are able to analyze the so-called carbonation depth, which is very well known in the bridge design, chloride penetration, and so on. So what is the main objective over here? The main objective is to have a very dense concrete, but it must be produced in a way that the concrete itself has still a certain flexibility when it is exposed to fire, since you need a certain volume of pores there in order to have a certain elasticity. And this is another interesting, let's say, a small chapel which have been created using only recycling material and some self-compacting concrete. Now, 5 million of cubic meter of concrete has to be casted. 60% of them cast in place, 20% for linings, and 20% for the spreaded concrete, approximately. So quality control is very much needed. The companies have their own laboratory. We are relating also to the local universities. We are trying to involve the laboratory there, and we do have our own laboratory in order to be able to prove all the times the quality of the concrete itself. Costs. Yeah. Approximately 8.5 billion of euros costs the total tunnel. We have been able to keep the cost since 12 years, and I'm sure that we will keep the costs also in the future. The tunnel costs the structure itself approximately 60%. The installation, the drain equipment, 14%. The management The land issues, this is quite an interesting, in Austria and in the northern part of Europe, the owner of a land owns the land to the center of the globe. Wherever in the southern part of Europe, the owner owns the land only the so-called usable cover, 30, 50 meters, not more. So we have to sign contracts with each property, with each owner on the northern side, on the Austrian side, in order to be allowed to pass with the tunnel under the individual properties. Risk management, 14% of risk have been included, and this is a big issue. We developed our own risk management. There are the so-called identifiable and quantifiable risks, which can be identified on the basis of experiences. There are some recognizable but not quantifiable risks. That means risks what we don't know. And finally, there are the so-called unforeseen big events known as the black swan. You know that the finance crisis in 2008 was a big event as well. The methodologies are the so-called probabilistic methods. We are identifying with experts some risks. Austria developed a guideline on the basis of experience for the recognizable risks, and I tried to develop a phenomenological approach years ago for the so-called unforeseen big events. Since we have to do something, we had also a big natural event a couple of years ago, and there is always the issue, can you foresee some measures in order to reduce the impact? This is the way we are using the Delphi method. We are trying to quantify the risks, and then it is the issue, are the risks really independent from each other or not? So we are calculating the probability of occurrence, the possible impact, and we are coming up with a so-called risk provision, and the management is done twice per year. On a yearly basis, we are calculating the value at risk, which is known in the bank business. It should be approximately 80%. Our risks are covered only up to 50%. This was agreed together with our stakeholders, and finally we came up with a total quantity of approximately 14% of the total cost of the project. Who finances such a project? On the basis of a state contract between Italy and Austria signed 15 years ago, exactly on the 30th of April, they divided the costs by 50%. And the whole project is heavily supported by the European Union. Europe pays for the project 40%, approximately 50% for the studies, for the planning, and 40% for the work. That means 40% pays Europe, 30% Austria, and another 30% Italy. If you cut it down to 20-year slice, there are small slices in the zone of 150 million euros per year per country. Working program. Yeah, the procurement have been done, first of all, in Austria for the so-called first phase, then on the basis of the Italian procurement law, and finally, some construction lots are now also tendered on under the Austrian procurement law. The so-called railway equipment has still to be tendered in the next year. We are over here, we are not going into detail, and we want to finish our work in 2027, and we reserved 1 year for the so-called pre-exercise in order to train the system, the rail system, and try to promote it. So what did we learn till now? We learned that in order to promote such a project, but in order to promote a project also in a city, you need a coordinator. The coordinator must work as an accelerator, and together with some international experts. Otherwise, they don't believe them anymore. This is a big issue. Then you have to have a vision for the next 20, 50 years. You have to have a communication strategy and a strategy for the environmental protection. And it is very important to work out a technical guideline, including the life cycle management, cost and risk management, and specifically for infrastructural projects to have a clear vision about the intermodal and multimodal mobility, how to change the modal transportation systems and so on. Another 7-8 minutes. 40 kilometers of the exploratory tunnel have been built, 100 kilometers are excavated, let's say, at the end of May of this year. Then we have to go further. We will be able to excavate approximately 20 kilometers this year on 4 construction sites. Giving you a little bit of flavor what we are doing, we are building bridges over here. We are trying to, this is the existing railway line over there, sorry, this one. The new line runs in parallel and goes into the mountains to the south. We are excavating 50% by drill and blast and 50% using some mechanized drilling system. The drilling machines can be blocked. At the moment, one machine is blocked, the other works. We have been able also to reach a world record for a gripper, which is an open TBM, as you saw that in the film, by excavating 61 meters in one day. 61 meters in one day. The normal velocity is approximately, let's say, 15 to 20 meters using mechanized drilling, drill and blast, 5 to 8 meters per day, not more. This is another big construction lot on the southern part of the Brenner. We will start with another 2 drilling machines on the 22nd of May of this year, and then we will have 4 drilling machines at the same time working, and from now on, in 1.5 years, we will have probably 8 drilling machines working at the same time. A very interesting construction lot is the underpassing of the highway and the river Isark over there. By creating some vertical shafts over there and using a freezing technology, and so we are underpassing the, let's say, the traffic infrastructures in the river itself by using this kind of technology. Now, optimizing drilling, innovations. We developed on the basis of the so-called performance-based excavation methodology our own system. We do have our own geologists. They are going on site on a daily basis. They are staying in the tunnel 8 hours. They are trying to work out what is, how the mountains, how the rock mass behaves. They are interpreting geotechnically the behavior, and finally they are transferring the data out to the office, to the back office. And I was using some sentence from Confucius who said, wisdom, compassion, and courage are the 3 recognized qualities of men's, of decisions in tunneling. This is a small drawing, what the geologists are doing. We are using boreholes, drilling a hole in order to see how the rock could behave. We are using also some scanning methodology in order to have a 3D imaging of the borehole, doing some laboratory tests, trying to figure out the fault zones, and finally, this cannot be done if you use a drilling machine. And we developed our own methodology also by using, let's say, the rotational energy and the translational part of the energy. We are saying if the drilling machine presses with approximately 10,000 kilonewtons to the rock mass, 1,000 tons, horizontal force, horizontal thrust to the rock mass. If they are rotating, then you have a certain penetration. This can be calculated, which is a volume. Volume multiplied with the so-called torsional moment gives you an energy. And that energy is used in order to identify the fault zones. And we have been able to develop this methodology actually one of our experts, by using the specific rotational and translational energy in order to identify the fault zones. And now we are classifying the rock mass in 4 categories. Green one, only with a little bit of support. The yellow one, which needs some additional rock bolts. The orange one, as you see over there, the rock behaves quite heavily. They are able to deform the steel arches very well. And if you are in the tunnel there and you hear how the breaking, the failures, and you know that you have more than 1,000 meters above you, it is a quite interesting feeling. Then I developed a very specific post-compressible steel arch system in very heavily pressed rock masses. We tried to use also, this was another PhD student from Greece, he developed the idea to use digital imaging in order to reduce the so-called extra profile, to have less tolerance by drilling and blast. We are doing nothing else. We are trying to do a picture, a digital picture, mixing statistics together with experience and trying to optimize the drilling scheme, nothing less. So this is a picture of the front. Then you see over there some pictures of the last 5 drill and blast stretches, adding them together, trying to figure out to optimize the drilling scheme. The overbreak limit is approximately plus 25 centimeters. The prediction line based on the forecast on the developed method is the red line over there, and the new drilling line is the inner line over there. And we have been able to reduce, through this methodology, the overbreak by 65%. It is a technology which doesn't cost a lot, which is quite easy. The only difference is the following, that in the past, the drilling master had a pencil and a piece of paper. Now we are transferring the data to a tablet. And they are quite proud they can use it also privately. Now, this is another issue. Clearly, if you are able to work more precisely, the ultimate load, the performance is much better. Another short innovation, and then we stop. We had the situation that we have to bring the material into the tunnel of a total length of 18 kilometers. In traditional tunneling, you are using rails or some tracks. The idea was to develop a so-called autonomous transport vehicle in order to bring the material, the tunneling, the material, what you need, the building materials, crossing the access tunnels, turning around by 90 degrees and going along the 15 kilometers of the so-called exploratory tunnel, having different slopes there as well. This was the special vehicle, a Swiss company who developed that. It can be created a big chain of vehicles, and we have been able, on the first time in the world, to transport 90 tons. Before, they have been able only to transport approximately 30-35 tons. With a new developed machinery, we have been able to develop that. And then we started we try to use them also in terms of an autonomous material transport system. And you will see that on the film. We started that experience the last December without conductor. There is nobody there. stops on the street light. That's around the curve. The velocity is approximately 23 kilometers per hour. Comes close to the big machine. Goes into the drilling machine. Distance over there is 25 centimeters. So this was a first try. We wanted to start that already 3 years ago, but the safety inspector didn't allow us that. And so we had to do a lot of measurements, a lot of research, and finally we have been able to promote it. The last topic, I would like to talk a little bit about communication. My proposal was always we have to communicate on each level, on the so-called young people level, on the family level, up to the scientific level. We do have 3 information centers, open 6 days per week. We have more than 25,000 visitors per year. We are trying to promote the project also locally through the news channels, information centers, open tunnel days, as you saw already, some internet portal, and the so-called Brenner Corridor platform, which is nothing else as a platform to promote measurements for the future. A very important issue was that you have to integrate the local traditions. In 2007, we had a lot of oppositions against the tunnel project. And so I came with my own choir to the open day. It was the first time. So the local priest and the local choir didn't sing. So they said, no, we don't want the project. Finally, and so I came with my children, my family, and so we tried to promote it. Some people have been there. The years later, in 2018, we had more than 10,000 people on 2 days in the tunnel with a lot of exciting, interesting visitors. Finally, in 2008, when we started the project, we had a short piece of tunnel already excavated. The project was under discussion, and the Austrian broadcast radio called me. Could we make a concert in your tunnel? I told them, oh yeah, why not? Then I asked my stakeholder and told me, yeah, we don't take any responsibility. If you want to do that, then you take it under your own responsibility. So the day came in the afternoon of the same day. I called my wife, I told her, and she said, my goodness, what have you done? So I went to the insurance company, I signed an insurance, a private insurance, and we had more than 1,000 young people in the tunnel, a rock concert. The next day, in the broadcast radio, they talked about the Brenner Base Tunnel. And so everybody said, why? Is this reality? No, we are still building them. And so you have to create some early dialogue. You have to create a basis of trust, which is very important. And you have also to solve critical issues, at least trying to solve that. The social impact in our project is quite interesting. We have 2 different design and construction cultures, 3 different languages, 3 different railway companies, 11 different languages spoken on site, and at least 11 different opinions. We created a network within the universities, and this is one topic what I was already discussing with the dean. We want to promote the young generation. We need you. You are the ambassadors. You are the next columns for the future, and we have to exchange as much as possible, promoting master thesis, PhD thesis, in order to develop special studies and research. And I would like warmly invite you to sign with us some letter of intent. We are creating jobs, clearly some investments, and we are trying to create some knowledge and innovations. Those are the 4 or 5 issues what we are trying to develop in parallel. And so this project will clearly be a key project for the European mobility in inducing new technologies, a new operational system, and hopefully creating also a new way of mobility. And so that what we learned actually are, you need some efficient organizations, fast decisions, which is almost impossible having public stakeholders. Sorry that I'm saying that. You need a solution-oriented and not a code-oriented, let's say, decision makers, which is also quite important. The management of costs, risks, timing and financing, and the quality. Some continuous environmental monitoring, some continuous communication, and finally, you have to promote also innovations, jobs, and technological growth. This will become the world's longest railway tunnel, and I hope that we are able to open also a new time, a new period for tunneling and for mobility in Europe. Thank you so much.